This episode of the Design Your Dream Home podcast is brought to you by Porcelanosa. With 30 showrooms in the United States and Canada, Porcelanosa is a luxury lifestyle brand that'll make your next project's dream into a reality. From a wide selection of tiles and mosaics to modern bathroom and kitchen cabinetry designs, Porcelanosa makes it easy to bring modern European design elements into your home. Visit porcelanosa-usa.com to learn more. You are listening to the Design Your Dream Home podcast with Doug and Steve. Doug and Steve are architects, and they're here to help you design your dream home. All right, so you guys know that, or you may know, I might have mentioned on occasion I go up to Penn State. I'm on the Arts and Architecture Alumni Board up there, and I met Joyce Hoffman. She was one who introduced me to the group. She is the Director of Constituent Engagement at the College of Arts and Architecture. And we have events from time to time up at Penn State. And I got to meet her husband, Norm Horn. And so I met Norm a couple years ago, and we've talked on occasion. Anyway, this past event up there, we have it's called Penn State Blue and White Game. And I got to sit and talk with Norm at length about architecture. And we got to talking about what he did. And he's a really interesting guy, very knowledgeable guy. So I'll give you a little intro on Norm, and then we'll hear from him about what precisely he does. So Norm is a design build project manager at Invinity Inc., and I believe that's in State College, PA. He's also a woodworker, and he's a certified passive house tradesperson. And so Norm and I started talking about passive house design, which is essentially creating very energy efficient buildings. And then we started talking about net zero architecture. I have a little bit of interest in that. At an AIA convention, I got to listen to a talk on that. And although I don't engage in anything, there's nothing green about the work I do per se, and I don't know a whole lot about it. I started asking Norm all kinds of questions, and so I thought he'd be great for this podcast. So welcome, Norm.
Right. Great to be here.
So Norm, why don't you give us a little background about how you ended up doing what you're doing, and then, what are you doing right now, and then talk a little bit about maybe some passive house design detail stuff.
Okay, so background. I came to Penn State fresh out of high school back in '93. Ended up getting my bachelor's in landscape architecture with a minor in photography and a minor in geography, and hung around and got my master's in landscape architecture a few years later. So, as the saying goes, 9.5 years in college, I'm no dummy. Um, I got into construction largely out of curiosity and necessity, because it was a good way to make some money on the side during semester breaks, summers. And I was always curious just about how things stood up. We talked a lot about design in our studios, a lot less about the construction details in those studios. And I was just kind of felt like I needed to know how things were going to get built before I could say, this is what I want to do. And one thing led to another, and here I am, like almost, 20 years of doing this kind of stuff full time now. Started out basically self-employed by myself, just subcontracting wherever I could get in. Did a lot of custom woodworking, staircases, kitchens, trim, nothing at all focused on sustainability, being green, or even responsible. That was all stuff that was, the sustainability word was one that never got back around when I was in school. And now when I get back onto campus, it's miles beyond that even.
Right. So how did you end up at Invinity?
A really good friend of mine from undergrad and grad school was one of the first employees there. So I had known those guys since they started. And the company's been around for about 15 years now. So, we worked together a little bit on and off, and, an opportunity came up to do something different. And it was time. It's starting to get stale, just doing the same thing over and over again. So it's great because it's always different. Every day is something new.
So
Well,
the
why don't
work
you
that you
explain what?
guys, go ahead.
Yeah, why don't you explain what Infinity does for guests? Excuse me.
So we're employee-owned design build firm. We're about 37 people right now, over three divisions. One big division is commercial engineering. They work with large healthcare facilities on HVAC systems, commissioning, and retro commissioning, system design. On the end that I'm in, we have residential energy services. We do HVAC system installs, service, and lately a lot of solar installation. And then what I work most closely with is design build, where we do everything from window and door replacements, performance upgrades, anything, recommendations that come out of energy audits that we do, up to additions, all brand new houses.
So a wide variety of different kinds of work.
Yeah, it is all over the place.
And so you and I talk specifically about passive construction. Could you give our listeners a little bit of detail about what that means, and then maybe get into the net zero stuff?
Uh, yeah, I mean, passive house, as it, there are two ways to go with passive house. There's the PHI, Passive House Institute, which is the German version, and there's the FIAS, the American version. Both founded in the same principles that, through thermal insulation, an absence of thermal bridging, good quality windows and doors, airtight building envelope, and fresh air ventilation with heat recovery. Through those five principles, you should be able to heat and cool a house with very little energy. So it's not like you're reducing your entire energy load by 90%, but you're reducing your heating and cooling energy loads. So that's the big takeaway for passive construction.
Let's say I have an existing house, and I feel like it just feels like it's expensive to heat and cool. Can I come to you and ask you to help me? And if so, how would we go about it? Would that be the audit you're talking about?
Yeah, we have a gentleman on staff who almost 90% of what he does is energy audits, and then he generates a detailed report from that audit for homeowners that explains, what their energy use is, what are their big draws, what are the big problems, what it would cost to fix big problems, what problems should be fixed immediately, what can be deferred, what the payoff or payback on those repairs would be. So I think it's a really good qualitative way of assessing, comfort issues in your home.
And so give me more detail. So what is that, just someone going around writing down some notes, or is there some mechanical, or are there actual measurements of different, heat loss and gain and so on?
Yeah. So his audits typically take about 4 hours. Um, the the big thing that everyone knows, everyone's seen the blower door test, right? So he
Okay.
will depressurize the house and get your air tightness measurement at so your number of air changes at 50 pascals. Um, we use infrared cameras to look for obvious air leaks, cold spots, hot spots, which they work better in the winter time. I mean, you have a nice delta between inside and outside temperature. Test efficiency of mechanical equipment, like if you have a gas or an oil burning furnace. Does a good dive into your your electric bill to see what's driving the cost behind that. So it's not all just walking around and spouting off opinions. It's
Right.
measured data.
It's amazing that you're using these heat sensitive cameras. I had no idea that technology was that functional currently.
Oh, yeah, absolutely. We use it all the time. And I mean, in new construction, we use them for basically verifying quality of insulation installation. We can see, where we might be a little bit thin, or sometimes things just get missed. They have these great things now. It's a little $200 or $400 dongle that hooks into your iPad or iPhone. So, I mean, really anyone
Oh my
has
gosh.
technology available to them now.
Yeah. You walk around your house and see where there's infiltration and where their heat changes, and
Absolutely.
that's incredible. So
Yeah.
are there fixes that are pretty typical for most people that have existing construction, or do they really vary?
It varies, but I'd say depending on the type and vintage of the home, you can kind of guess what you're going to get into before you even get into it.
Right.
A lot of new construction around here, we find things are surprisingly pretty tight, but not ventilated well. Or we say exhaust only ventilation instead of balanced ventilation. Windows and doors are a constant issue. Lack of or inadequate levels of attic insulation is another common one. It's pretty easy to fix. Wall insulation, and that's something that we can find with the IR cameras.
Do you guys, is the advice to get solar something that's pretty typical for you guys, or is that something that's only good for certain homes, not relative to their position and the sun, but other issues?
I mean, right now, I think it's a great thing to do if you have the all electric home. I mean, obviously, you can't offset fuel oil, you can't offset natural gas use, but if you replace those furnaces with electric heat pumps, and you have good solar orientation that you can use to offset their use, then sure.
Huh. So I'm sorry, Stephen, did you have anything?
Well, we just installed a solar system on our roof. I have a flat roof, modern home. And what made it attractive, I'm in Massachusetts, was it was actually the tax incentives.
Yeah.
And I think that those seem to be, I don't know, diminishing, or they're getting less advantageous sort of in different
So
stages.
you probably got a 30% federal tax credit with
I think
that.
so. This is based on last year. And I think this year it's actually getting less, there's less incentives. Is that something that's happening? Is it sort of trending in that direction, or is it trending in the opposite direction?
The 30% is set to go down to 26 and then to 22,
Okay.
and then it'll go away. Hopefully, it'll come back.
What's the motivation for that? Why is it becoming less? Why is it not going the other direction where they're encouraging it, so that encourage homeowners to explore alternative energy as opposed to electricity or whatever?
That's a great question. It's a little bit beyond my involvement with solar stuff.
Politics.
I joke that, anytime I do one of these things, like, the conversation always goes to solar, which is
Oh, really?
arguably my weakest thing. But to my understanding, it was one of those programs that was set up many years ago, and at some point it had to scale down and expire, hoping that the market would pick up and it'd be self-sustaining by this point. That wouldn't need a 30% tax credit to
I see.
get going.
So it would just make sense. People would do it just because it makes sense long term.
Yeah.
Although, so strangely, I work in Florida also, and they don't have any of these things. They have like constant sun all the time, and you don't see any solar panels. And meanwhile, in Massachusetts, where it's like raining and cold as usual, there's like very little sun, and everyone has panels all over their houses.
Yeah. And I'm sure everyone will say, why would you do that? The sun never shines in Massachusetts, right?
Right.
You know, we do the same thing. The sun never shines in Pennsylvania.
Right.
So, Norm, we talked a little bit about net zero homes. Could you explain what those are, and if that differs at all from what we're talking about, passive construction or passive home?
They're all very closely related. Net zero obviously is that you're looking to balance energy inputs with energy use so that you come out at a zero net usage. There are several programs around, like this time last year, we were finishing up a little duplex that I think you said you got a chance to drive by, Doug, that is Department of Energy net zero energy ready home certified. So the idea there is that if you would add solar PV capacity to that residence, it is ready to be completely offset. And we turned them over to the owners with PV on the roof. And I mean, by all metrics, they are net zero. And I think they might have gotten like some $3 to $7 electric bills over the winter.
Unbelievable.
Yeah.
So you can essentially build a house that costs nothing to run.
Yeah, I mean, basically, I mean, they have obvious electric use in plug loads, kitchen equipment, but there's the ERV bringing in fresh air. There's electric heat and air conditioning, so they don't have and heat pump water heater, so they don't have a gas bill. They don't have a fuel oil bill. It's all electric, and it's pretty much all covered.
So there's some math there, right? So if I'm doing a new home or buying a new home and it's net zero, it must cost more to create a net zero home. And then you've got to sort of figure out then what you're saving over each month over however many years you plan to be there, something like that, right? So what would be a cost? I know this is hard, but how much more would a net zero home cost by percentage than, let's say, I don't know, your standard home?
Oh, yeah, that's a great question. It always comes up, and it's always difficult to answer because I mean, as you know, there's so many variables.
Yeah. But is it twice as much? No.
It's absolutely not twice as much.
Right.
I mean, I think if you did it frequently enough, like a production builder knows what, this model of house is going to cost. If you're doing it frequently enough, I'm fairly certain that you could be, to within 15% easily.
Okay.
Upcharge. But, think about those little houses. I mean, if they don't have $150 plus a month electric bill every year, every month, I mean, that's, $1,800 a year right there.
Right.
So, what you save or what you spend in your first cost, you end up paying for fairly quickly over the life of the home.
Right. So, no, you don't have to sell me on that. I agree with you.
It's unbelievable. So I went on one of the websites that you recommended. It was 475. The company's called 475. So they're based out of Brooklyn, and they sell a lot of these green building construction materials. And they've got these amazing wall sections showing precisely how walls are built, the roofs are built, the floors are built. One of the things that they're doing is they have these double stud wall cavities. And they're using, so they've got dense pack, is it Gutex thermofiber or cellulose or Havelock wool loose fill insulation. So there are tons of different kinds of insulation. And I'm most familiar with closed cell insulation. We talked a little bit about this. So could you just tell us a little bit about closed cell and versus some of this loose fill and cellulose, and what we're doing with these wall cavities and why you're putting it in there?
Yeah, typically when we do a project, our go-to for cavity fill insulation is going to be either spray applied or dense packed cellulose, which is, ground up newspaper, recycled content. When I say it's spray applied, it's shot at the wall, kind of like gunite concrete. Has a little bit of moisture and maybe like a cornstarch sort of binder to it. Sticks in the wall cavity, and then the installer will shave it off flush with the face of the framing, and a little bit of moisture goes away through evaporation, and you're safe to hang drywall. Or you have some kind of interior netting or membrane that retains dense packed cellulose, where you just dry fill the cavities. That coupled with some sort of continuous exterior insulation, I think creates, just a great thermal barrier. It minimizes, if not eliminates, thermal bridging. I try to avoid closed cell foam at all costs.
Okay.
I mean, it's one of those materials that on the surface, it sounds like a great idea, but the deeper you dig into it, the more you find out, the worse you realize it is.
Well, why is that?
I mean, one big thing is, just the chemical content in it. I mean, the global warming potential alone in closed cell polyurethane should scare you to death. The fact that the installers are dressed up like spacemen, that should scare you to death too. Basically, this is like gallons and gallons of toxic chemicals that are mixed on site, like as they go into your house. And if they're not mixed exactly correctly, they don't work. So if you screw up the mix on, some epoxy glue, it never hardens. That's basically what happens with this stuff. So if it never hardens and it's always off-gassing some sort of disgusting chemical in your house, that's a problem. And it's not a problem that's easily fixed.
Right.
So let's underscore this point then, okay? Because I'm actually writing this down. So what is the recommended insulation then?
I mean, I like cellulose.
Cellulose.
Or I mean, wood fiber is great. It's at this point it's a little cost prohibitive around here.
Okay.
Mineral
Wool.
wool is really popular. I mean, it comes with its own penalties of embodied energy.
What does that mean?
Well, I mean, it's, like fiberglass is heated up and spun glass to make the fiberglass bats. Mineral wool is heated up, spun rocks. So it takes a fair amount of heat to melt rocks.
Okay.
So you have to think a little bit about the amount of energy that goes into making the insulation versus what it will conserve over its lifetime in service in the house. I mean, if you're going to use foam, I like the black Neopor EPS, which is expanded polystyrene as opposed to XPS, extruded polystyrene, which is kind of like the board form of closed cell.
So you like the idea of spraying in walls, right?
No,
you don't like spraying in. Okay, so you don't like the spray. You'd rather have the mineral wool or the cellulose products.
Yeah, definitely.
Okay.
Definitely.
And we talked about these being cavities that you're spraying into. How deep are they? I mean, I know it can vary, but are we talking a foot? Because the only reason I ask is you're taking away from square footage, functional square footage on the interior of the house.
Right. Next time around, next place we build, I'd like to throw as much insulation outside of the framing as possible, do as much continuous exterior insulation, than do the big 12-inch thick double stud walls. Because it takes, probably twice as much square footage in the wall
Right.
you lose from the house. So
I mean, we in a lot of our projects, people are asking, and we sort of are doing them. We're using double stud walls,
yeah,
and so it's working because we're working in urban environments. It works for sound. Besides energy, we use
yeah,
triple insulated windows. A lot of people don't realize you can have these super insulated walls, and as soon as you start putting like outlets and plugs and switches, you're basically putting holes in all the things that you work so hard to insulate, and those become places for leakage. And so, just having these double stud walls, it seems like the easiest way to create a sort of net zero home. The issue being that you're basically building almost like two houses because you're building the walls twice, right? So I think that's the kind of challenge. And as Doug mentions, you do lose square footage, although usually for freestanding homes, this is less an issue. I think it's more like if you're doing a series of townhouses and you're doing 20 of them, and now you've got 20 times every building is like 6 or 8 inches, or maybe a foot bigger than it could be. Now times 20 is 20 feet. So that's when it really starts to add up and you start to lose space. But for a single family home, we found that a double insulated wall construction is less about the size. It's more about the cost of having to build the house like twice.
yeah. That's definitely something to think about. I mean, the one big job that we have going right now that we're finishing up was double stud, and I mean, yeah, a foot thick wall is great, but
Yep.
yeah, it's twice as much lumber that
Right.
goes into the wall, all the labor that goes into the wall, plus the difficulties of having, to stitch those two together.
Right.
And that's why I like the idea of the continuous exterior insulation, because then you have that one good solid, say 2 inch, 3 inch, 4 inch thick band the whole way
Mhm.
around the house, rather
The
than it's broken.
the one aesthetic thing that we found about the double wall is that if we set the windows in on the first or inner layer of the studs, then from
Mhm.
the outside you really do get that window that's not flush with the exterior. It's actually set in like an old house, which we
Right.
like. So it costs more to do it. We have to have a sill, we have to build surrounds, but it just looks like an older home because where you had like, thick walls and the window was sort of set in, as opposed to these newer houses where the window is kind of flush with the outside. You really can't sort of read the thickness of the wall. So that's something that we actually like in terms of what's its look, the aesthetics of it.
Yeah, you get some great articulation
Right.
in your elevations. It's one of those things that a lot of people can't put their finger on, but they know they like it,
Hmm.
as opposed to your standard flanged window application where just everything's one solid plane of siding, windows,
Right.
flat,
Wallpaper.
boring. Yeah.
Exactly right. Hey, so here's a question. Can you make an existing home? Can you make it net zero?
Yeah, you could,
Can.
you could absolutely do like a net zero retrofit or even passive house retrofits.
Hmm.
Yeah.
So where would you look? Where would you sort of zoom in? Like where would you kind of narrow in? Say, okay, here's where we need to look. This is how we would start to do that. What would it be?
I mean, obviously it's a case by case thing, but
Yep.
building envelope is the big thing.
Okay.
Um, obviously your exterior walls, roof, and windows.
So it's more that than the systems. It's more the building envelope, you say, than the HVA system.
Yeah, because I mean, you can have the most efficient HVAC system that you can buy, but if you put it in a poorly or uninsulated structure, it's not going to keep up.
Okay.
So, our approach is get your building envelope right, get your thermal insulation right, then your mechanical systems become much smaller, much more manageable. So they're going to cost less to install the first time.
Mm-hmm.
They're going to cost less to run every month. They're going to work efficiently. They're going to take up less space out of your house, less complicated. So,
It seems that like whether you're a net zero person or not, you should just have an audit done in your house. I mean, it takes 4 hours. It probably costs, I don't know, X, but like, why wouldn't you do it, right? I mean, because it seems like there are probably different layers of measures that you can perform to make your house less costly to run, right? I mean, and
Yeah.
it seems like it would make. Why wouldn't you do it?
Right. Yeah. I mean, we charge, I believe, 450 for an
Right.
audit. There's a $250 rebate through the
Oh,
utility company.
okay.
So cost to the customer is like $200.
Right.
Plus, there's some freebies that come along with that. So you're essentially you're not in for very much money, and you're going to save money provided that you know use those takeaways and just make some changes.
Right. And I'm sure that there's a lot of homeowner fixes that are easy, sort of, easy ones that they can do. And there's probably various levels of, what you need, but I'm sure that there are some easy pickings, right? There's some easy things you can do, seal windows or add some
Yeah,
insulation in the basement, what have you.
yeah, yeah, absolutely. I mean, I personally, I think that's something that should go along with every real estate transfer.
Hmm.
You're used to the home inspection, where the guy comes out and tells you if the roof is at the end of its lifespan, or your electrical service is undersized, but nobody tells you, hey, I think you have no insulation in these walls. That's going to cost you a lot
Right.
over the next couple of months, much less, over the next couple of years. So, I mean, why not make that part of real estate transfers?
Well, that's a great idea. Be an interesting part of a business. Um, Back to construction for a second. I went online. I looked at a couple of the links that you had sent. One of them either took me directly to, or I ended up on a website that was featuring 8 net zero homes. They were small, they're relatively small homes. And all of these homes had open floor plans. Can you tell me a little bit about that? Because I know a little bit about the slab on grade thing and the concrete slab absorbing heat and then the heat moving through the spaces. But why do they do that?
You mean just for passive solar orientation
Yes.
and
Yeah.
and heating?
Yeah, just for the heat gain and for the net zero effect.
Yeah, the last couple of houses that we've done have been either slab on grade or have had, large expanses of south-facing glass with either concrete or tile floors, basically to take free BTUs from the sun.
Hmm.
A couple of these places, I mean, you can walk into them on, bitterly cold February days when it's in the 20s, but as long as it's sunny,
Yeah.
they're great. I mean, you can't. It's a double-edged sword, though. I mean, you can't rely totally on the sun for that, for your heating, because it's not as predictable, right? And there's some criticism that uh, using passive solar to warm up your floors takes too long to bring it up, and then it takes too long to cool it off. If it, so you're always sort of fluctuating off out of phase with your comfort needs. But it's free BTUs.
Right.
Well, as long as it's done sensibly, and you don't just throw some windows out there without calculating your shading and getting your proper windows, like as far as coatings go.
It's funny because I think that guys that grew up, let's say in the 70s, and when people were worried about, I mean, in school we talked about passive design, or I think a lot of people have not really experienced or have a lot of experience in these areas, so that when building a new home, I'm sort of surprised to see that the architect maybe hasn't even really considered the exposure orientation. They're more worried about aesthetics or other things. Um, so does a company like yours, let's say that somebody is not well versed, and I don't know, a lot of architects will admit that, but let's say that they're not well versed in some of these principles, and say, hey, um, maybe we can talk to you and you can consult and advise and make sure that what we're doing will be there's some good passive design principles that are here. Or maybe it's the homeowner that says, hey, I like the design, but let me just kind of have a consultant to, advise. And maybe it's a builder style home where someone's almost buying plans or whatever, but can they then sort of talk to you and consult with you and say, hey, listen, we like the look of this house, but it doesn't seem like a lot of it makes sense. Can you help us to, I don't know, correct or make this a more passive design oriented house?
Yeah, we do that all the time. And, contrary to stereotypes, there are architects out there who will admit that they don't know
Oh,
everything.
okay.
I'm working with one right now who's sort of chugging his way through schematic design, and he bounces drawings over to me and says, "Hey, is this getting to be too much glass on this side of the house?
Okay.
What do I need to think about wall thickness wise over here? Does that take up too much space out of this?
Mm-hmm.
Do we have, I give them feedback on like whether they have, if they're setting themselves up for failure as far as like efficient hot water distribution, other efficiencies in mechanical system locations, so that you're not, piping hot water to the complete opposite end of the house or conditioned air to the other end of the house. I encourage people to get someone who is knowledgeable on green building and building for efficiency involved from the beginning, as early as possible, rather than saying, buying some plans and saying, hey, make this green. And there are some things that are just, frankly, they're too far gone.
Right.
So if you have the opportunity to do it right from the beginning, do it.
What we've talked about as part of the process, let's say that a homeowner wants to retain an architect, and then the architect may come with a list of consultants, people that he or she thinks that they need to help make this project a great project, and for all the different sort of areas. There are times where someone, let's say, needs a lighting consultant. We just feel like this person really wants a high level of lighting design. We should bring a consultant on, and you're right. I mean, there are certain jobs where I feel like I can do certain things, but if there needs a sort of different level of expertise, I'll bring in a consultant. I'll bring a lighting person in, or a landscape, or never interior, but there. And so a green consultant. We also work with green consultants, and you're right. We do it from very early on, where we talk about our basic approach. And then maybe through schematic design, we'll sort of check back in and say, hey, how is this looking? And so in the end, I mean, I'm not an expert at that. I've learned by working with consultants and just just some general knowledge. But if an architect is, and this for homeowners, is sort of advising, why don't we bring on a consultant or two? I think it makes sense. I think it's maybe part of the cost of the overall fee, the design fee, but I think it's worth it to have that extra set of expertise or eyes and expertise on a project. So I would definitely recommend a green building consultant if that's importance to you.
Yeah, no, I'm a big fan of collaborative approach to things and just letting people do what they're good at. Like you mentioned, lighting. I never want to touch lighting because I don't know. So it makes sense to get somebody who does know what they're doing in there.
Yeah, the joke is that with lighting and landscape, if you see an architect's plans and the reflected ceiling plan, all the lights are like equally spaced and raining down the middle of the hall. And then you look outside and the trees are like lined up and running along the front of the property. You know that an architect did everything and didn't really think about what it was going to be like. They just sort of lined everything up. So
yeah.
Probably our solar panels all lined up on the north side, south side, so they're balanced, not really knowing what they do.
That's great.
Yeah, make a nice ring around the edge of the roof.
Norm, I got one more detailed question for you. So I think it's probably 15, 20 years ago now, Drive It had a huge problem in the United States, lots of lawsuits because water vapor was getting trapped in the walls. It was rotting the structural parts of the walls. This isn't necessarily a question in regard to green building, but it does have some relation. I'm looking at these wall sections, and they've got this back vented siding system. So
Yeah.
you've got this exterior air barrier, which is also, I'm assuming, insulation, and then you've got these wood slats or some sort of slatted system, and then you've got your siding. And so you're allowing, at least from what I can tell, any water vapor that gets in to escape. And the same is going for the interior. We talked about the use of vapor barriers. We don't call them vapor barriers anymore because there's a concern about trapping water vapor on the inside of a wall. So could you talk just a little bit about water vapor in these wall systems and what you're trying to do with these thicker walls that have lots of insulation in them?
In a nutshell, what you're trying to do is allow for assemblies to dry out if they do get wet.
Okay.
And, first line of defense is preventing them from taking on any moisture. But if they do take on anything, allow it to get back out.
Okay.
So if you think about it in your exterior finish context, I always tell people that siding will leak. It's a known fact. Deal with it. And I always try to make sure that we have twice the capacity for it to dry out than we do for it to take on water. So
Interesting.
we're always doing a back vented rain screen application for siding.
Always.
Yeah. So we always have some kind of cavity back there so that when water does get in between, whether it's board and batten or wood, fiber cement, claps, whatever,
Yeah.
it can fall right back out the backside and drain away.
So for our homeowners, you're not applying the siding directly to plywood. You're applying it to wood strips or slats that are applied to the surface of the house.
Yes.
Okay.
We'll use either wood or there's some other products that are like black polyethylene plastic that they're thinner and you just nail right through them. They're kind of like corrugated plastic, like politicians' yard signs are made out of.
Sure.
Yeah.
And then what about on the interior? So we're talking about water. So water can get through the siding and it may get through the exterior air barrier, or it cannot get through that. What's that?
It better hadn't get through the exterior barrier.
Okay.
Yeah, that's the big line of defense on the outside is the weather barrier.
Yep.
Most commonly known to everyone is something like you see Tyvek,
Okay.
or like your local lumberyard branded house wrap,
Yep.
typically flapping in the breeze like a haunted house,
Yep.
installed upside down, installed sporadically.
Sure. Now, I'm asking all these questions, but you talked about adding insulation to the exterior of your home. Where would the insulation fall in that system? Behind the Tyvek?
It depends. I mean, depends on the material. So we could do something like, say, plywood sheathing, then a weather-resistive barrier membrane, then rock wool or EPS foam, then furring, then siding.
Okay.
Or some of the wood fiber insulations are their own weather-resistive barrier. So you can do those even sometimes without sheathing, as long as you're braced for shear.
Okay. And then on the interior, water vapor relative to, what's happening on the inside of a building. Where does that barrier go?
You want your vapor retarder to be as close as is practical to the living space.
Okay.
So we'll use something like an interior, vapor variable membrane that's airtight. What we don't want is to have air from inside the house, pushing through the building envelope, and getting to the outside,
Okay.
or vice versa.
Because if air is, then water vapor is.
Yeah, I mean, there's vapor drive, which carries, very little water with it. But if you have an air leak, the amount of water that air leak can carry with it into your walls is, significantly more.
Okay.
We're talking about the difference between like an eyedropper and a bucket.
Wow. So how does a vapor retarder like that differ from, say, the old school way of doing it where they just took giant sheets of polyethylene and stapled them to the wood studs?
Yeah, the giant sheets of 6 mil poly, put those up, and you have to cut around every window penetration, every door penetration, every place you have a light switch or a receptacle. So it's not a continuous airtight layer.
Okay.
It's largely airtight. It's kind of like a leaky greenhouse, right? So air's not going to be able to go through, or air leaks and vapor drive aren't going to go through the wall, just out in the field of the wall, but around your receptacles. You feel that draft.
Yep.
Because there's no polyethylene right there to stop it. So it goes through, but then it can't get back out because
Right.
most of the wall is, once it's in there, it's in. And then because most of the wall is covered with 6 mil poly, it's not going to easily get back out. So it's always going to retain some of that moisture and just be kind of funky
Got it.
in there, which leads to rot, indoor air quality issues.
Do you have a device? Because I'm just thinking my own home and a lot of the homes that I see, they're built a certain era and they have bad insulation, the pink stuff. Do you have any kind of device that's almost like a camera that you can feed through walls? Because I'm terrified to see what's in there. I feel like those walls that stuff is degraded, and
They're all
I don't
rotten.
know. There's things living in there. I just can imagine it's like the worst stuff. It's basically degraded fiberglass that is off-gassing into my lungs every day for my entire life, right? I mean, I just feel like maybe I don't want to know, but do you have devices like that can help say, hey, listen, this is not my opinion. Here, look at the photos. All the insulation is dissolved and it's like full of mold, and there's animals living in your walls. I mean, maybe here's some corrective measures.
I mean, they're the little flexible scope cameras. I mean, those are pretty easily accessible to consumers now. I mean, all the big name tool manufacturers make them, for plumbers and electricians. You can stick that in there. There are things like, you can stick moisture meters and moisture sensors into the wall. That you can, little data loggers, so you can know, over the course of weeks, months, a year, what the moisture content in your wall is. A lot of people do that, like on the back side of their sheathing, to see, when that surface is condensing. Or you can just yank off drywall and
Norm,
Good.
what is your opinion about attaching a kind of a greenhouse to a south-facing living space, so that in the wintertime you put plants in there, and year-round you can sort of open the sliding doors and let, I don't know, the good air come in, and it's heated, and I don't know, in the summertime I guess you open it up because it's like would be a million degrees in there. Is that because I saw somebody build a greenhouse around their house, like in, I don't know, Denmark or something. Yes, Sweden maybe, or something like this. And I was sort of wondering, as a retrofit, adding a greenhouse to a building, just an extension of the living space. Does that make sense? Is there any good reason for something like that?
I would say no.
Huh.
I mean, typically the retrofits that I get involved with that have a greenhouse or, the fabled 3-season porch component.
Yeah.
It's typically making it go away or making it habitable. I mean, we've had several of these things, where they're just not habitable for more than literally like 2 weeks out of the year, and they might not be the same 2 weeks in the same month.
Because they're too hot or too cold?
Yeah. Yeah. I mean, like
Yeah.
entire rooms of the house that are just useless, and they're always frozen or they're 100 degrees.
Hmm.
Yeah.
On your south side, yeah, I mean, you're going to overheat in the summer.
Hmm.
And with that much glass, you're likely to create some sort of moisture issue. Yeah, it's just not a
That's
great.
not the way to do it. Okay, got it.
So, yeah.
So I
I mean,
wonder about that house though in Sweden or whatever. They built the glass enclosure around their regular house.
Oh my gosh.
I wonder if in the end I can see it I see it in like a Dwell magazine, like, oh, this couple makes this greenhouse around their regular house. And I'll think,
yeah.
is that a good idea?
For $125 a square foot, and they did it in 3 months by themselves. The classic Dwell.
That's
Yeah,
right.
the whole trom wall thing. I mean, I think of that as kind of a Mother Earth news method. It has some validity to it. I just think that there are so many easier, more cost-effective, proven ways of doing things
Hmm.
that you don't have to get into taking the engineering leap of faith or the
Okay.
physics leap of faith.
Right.
Yeah.
Thanks. Save me from building a greenhouse.
You don't have a greenhouse in your place, do you?
Oh, I was thinking about it. I was like, it'll be nice to have a greenhouse.
Yeah.
Maybe
No.
not.
Well, Stephen, do you have any more questions?
No, I
for
mean,
Norm?
I've asked a lot, just actually very personal questions about my own home. So,
Well, Norm, I
maybe
can't tell you how valuable this has been. I think this is probably the best episode we've done in terms of technical detail stuff and building technology. And it's all really interesting. And it's probably a little familiar to some of our listeners, but not that familiar to most. I certainly hope I get a chance to use some of this technology going forward as an architect. I don't get a lot of opportunities to do this. And, up until I think 5 or 10 years ago, most of these things were cost prohibitive, or at least I know in our office when we looked into this 15 years ago,
Yeah.
all of the construction technology just really wasn't there. And if it was, we were spending a fortune to build houses. So things have really changed. They've come a long way. And it not only is it interesting, but it's extraordinarily valuable. I can't imagine being able to live in a house that costs almost nothing to operate, because I know I live in a house that was built in the 1960s and it's a nightmare. I mean, it costs a fortune to live here. So anyway, Norm, this has really been great. And I really appreciate your time, taking an hour out of your day to do this. And I look forward to talking again at some point. So thanks very much, Norm.
Yeah, well, thank you both for having me. I mean, I was scattered and really all over the place, but
that's our fault.
more than
Yeah, it's my fault, Norm.
totally cool, totally cool. I'm happy to talk about it anytime. We can always dig into more detail on some of these things.
Sounds great, man. Well, thanks very much.
Thanks,
Sure,
man.
thank
You've been listening to the Design Your Dream Home podcast with Doug and Steve. If you have any questions or want to give us any feedback on the show, feel free to reach us through our website at thedougansteveshow.com. Thanks for listening, and we'll see you next time.